A little bit about me. I'm Christian Ledermann. I work for UNITSA. We are doing enterprise technology management. Today I'm going to tell you a tale of two kitchens, or more precisely, how to hypermodernize your code base. You don't need to take any pictures of the screens. The presentation is online. Comes in the last slide. Okay, short overview. So what are we going to do? Go through what actually is hypermodern Python, why you want to use the hypermodern Python approach on your code base, and then when you have legacy code, how to apply these hypermodern concepts to your legacy code. So hypermodern Python is in principle an article series by Claudio Jolovic about 2 years ago now, I think. And it's an opinionated guideline to best practices and clean code on Python 3, how you should can write that in the 2020s. So when you go to the hypermodern Python cookie cutter page, you will see that there's a lot of things that go into there. So, and I won't touch on everything of that, and I will mention a few things that are not in the hypermodern cookie cutter. So, but back to our thing, it's a tale of two kitchens. So when you look at these two kitchens, what kitchen would you rather like? So which kitchen is better for security, for health and safety, to deliver fast or deliver high quality food, job satisfaction, on personal growth? So hands up, who thinks it's kitchen 2? Oh, less than usual. And actually, the kitchens in which we work quite often look like this. So why clean out your code base? Yeah, really, if the code is formatted, it looks the same everywhere. It's just minimizing your context switches. You don't have to get in somebody else's head how they wrote it. So in the lean sense, that is to eliminate waste. Also, when you think about the broken window theory, when you go somewhere, when you go to a house, there's one broken window. It is quite likely that more broken windows will follow, and it may even, for the whole street, lower the prices. Also, the Boy Scout rule: always leave the place better than you found it. It's much easier if the place is kind of clean to begin with. And yeah, overall, to improve quality. But actually, don't take my word for this. John Carmack from Quake and Doom, he said a little time ago, the most important thing I have done as a programmer in recent years is to aggressively pursue static code analysis. Even more valuable than the hundreds of serious bugs I have prevented, with it is a change in mindset about the way I view software reliability and code quality. John McCormack is one of my programmer heroes, so I heed his advice. Oh, how to get started. So, first of all, start small, start simple, and don't delay it. Just get it going. First of all, yeah, format matters. And you want to have every member of your team applying the same formatter. So pre-commit is yeah, a great tool written in Python, and so easy to use. It's an obvious choice. And then when you start formatting your code base, yeah, start with the one where you won't get any pushback. Imports are normally not something you have much discussion about. So yeah, I thought Again, a really obvious choice. And then you can add other tools like Absolufy imports that converts all your from dot or from dot import something to expand it to the full package name. Together with isort is great. Unimport will just remove all your unused imports, which is also great. And if you have that in pre-commit and when you run your test, you will easily catch if there's an import needed that is not used, but you have to import it. So, and there's also a remove star. So if you have from something import star, which pollutes your namespace, it will actually try to resolve everything that is actually needed in your code and then just import those functions. Then to format code, there are some choices, but really black is pretty much the gold standard nowadays. And if you don't like double quotes, okay. If you want to die on that hill, be my guest. And then rough has, anybody heard of rough yet? Okay, a few people. Rough is pretty much Flake 8 re-implemented in Rust. And it does a superset of a subset of Flake 8, and it does it lightning fast. So it's 1-2 orders of magnitude faster to check your Python code. But on the other hand, it doesn't have all the nice plugins Flake 8 has. So, and Flake 8 has a lot of really valuable plugins that come in really handy. Also, what you can do brilliantly with static code analysis is security checking. Bugbear it's not so much geared at security, but it will point out some common mistakes. So if you ever had a default value for a variable in the function call empty list, Bugbear will catch that and telling you not to do it, and actually tells you also why not to do it. Bandit is a security scanner that finds common security issues like, don't use random, use security, do not pass HTML as strings to your template engine. A whole lot around this. Also very useful tool. Safety and DependerBot mainly look at your Python package versions and tell you what's outdated, where there are CVEs for what you really should update. And there's also PISA, which is really for advanced. It's part of the Pyre type checker, and that has some advanced security features in there, so you can follow an input, so you don't have tainted strings that may come from a user input go into your SQL or something like that. And start measuring things, because you only improve what you measure. And for tests, the obvious thing is test coverage. And then when you do a pull request, you probably want to know how good is your diff covered. The code is coming in your code base new should be well covered. Then we have actually quite a lot of complexity measures. So McCabe is actually built into Flake 8. Radon is a standalone tool. Xenon actually only adapts this for CI reasons. And a lesser known one is Lizard. That is a bit relaxed than radon, but if lizards flag something up, that is, you should really look at that. And another thing is a cognitive complexity scanner, also available as a Flake 8 plugin. And that is yeah, a bit more advanced than the above complexity scanners, because it also takes in things like recursion into account. So it really fits more the mental model of a human than the other scanners. So typing. Okay. Yeah, in the 2020s, we should really type our code. Okay, if you're only writing one-off scripts, yeah, we really don't want to do this. But if you are working over there and the enterprise, rainbow-colored enterprise unicorn software that you're working on, you really want to have types, and you want to check your types more than just simple documentation. So MyPy is, yeah, normally the weapon of choice. But yeah, then you have we're talking about legacy code base. So maybe even coming back from the times of Python 2. And there's a little tool called MonkeyType, which observes your code while you execute it. And it observes the type, the flow in your functions and flow out of your functions. And it does a very good job out of it. So if you parse a dictionary, and the dictionary has all the time the same structure. It not only says, okay, that's a dict of string and maybe any. You get a type dict. Okay, this dictionary has these keys with these types, and that was really amazing when I first ran MonkeyType, that it could do type dicts, and I knew what actually goes into and out of the function. Then there are the other type checkers. So there's Pyre from Meta, PyType from Google, and PyWrite from Microsoft. And if you have a partly type annotated code base, they can infer types about what they observe statically analyzing your code. If you have untyped code, they don't do much. They will annotate a return type of none to your init, to your dunder init function, and such trivial things, which is also a good start. Less to type. And, but yeah, with a partially type annotated code base, it's maybe a nice idea to try that. And yeah, TypeGuard lets you, in runtime, check your types. So it's a runtime type checker. Okay. While you may not want to do this in production, you may want to run your test with it. So you know that during your test execution, you always pass in the right types, that you're not trying to make your code break on an unrelated event. Okay. Modernizing your code, also you should pay some attention to your tests. So if you're still on unit tests, Tayit is a really nice tool to modernize your unit tests. So if you're, especially the assertion, so self-assert, is self.search equal is instance my var some type true will be converted to self-assert is instance of type. So it gets really much more readable, your unit tests, especially if they have some years behind them. And if you want to change from unit tests to PyTests, there are two tools that help you with that. I used PyTestify. It had really worked really great for me. And there's the older one, unit test to PyTest, which also does a really decent job. And yeah, testing in the 2020s. We should do more than what we did in the past. Hypothesis is a property-based testing system, which means it generates a whole lot of example data, puts it into, throws it at your code, and then yeah, you look if something breaks. And it does this in a very intelligent way. So if it finds an example that breaks, it tries to narrow down why it breaks. So if it's a long string with a null character in it, so then you try, okay, let me try just the null character. Let me try 2 null characters. What is the smallest thing that can break the code? It does a really great job with it. And it comes with a ghostwriter, which you pretty much tell, okay, that is a function I want to test, write me a test scaffold for that. It's, especially if you're getting started with a hypothesis, great. A great way to get started. So sometimes I actually know what my function takes and returns. So I know the structure, and usually that is the case for Open API web applications or GraphQL web applications. And Schema Thesis does exactly that for you. It looks at your Open API documentation, that YAML or JSON, and then generates test data for that. So everything what Schema Thesis thinks is legal to put into the endpoint, it tries out. And it is amazing how much things you find with this. Even if you have 100% test coverage, I'm almost certain Schema Thesis will break your API. Also, Schema Thesis, you don't actually have to install it on your machine itself. It's available as software as a service. So you give them the provider just the URL where to find your schema, and then it begins torturing your API. Quis custodies, or who is watching those watchmen? How can you tell your tests are actually testing what you, testing everything in there? 100% code coverage, okay, sounds good. But what if I change a little tiny thing in the code? Will my tests catch that? Will the test then flag up, okay, yeah, you changed something, this is now broken. So maybe instead of a for I equals in range 5, okay, then it would just try, okay, what about range 6? What about range 4? Does it still work? If it works, it's a mutant that is untested, and it runs it again. Again, you find lots of edge cases you haven't thought about in your code with this tool. but but only run that on small snippets of your code, because it really takes ages. I have from seconds to run a simple unit test on library of mine. It goes into 5–10 minutes to test everything with mud. But again, it's really helpful. Upgrading. So there are, first of all, tools that bring your Python up to the newest idiomatic Python version, like PyUpgrade, which does a lot of things. If you still have a Python 2 code base, PyUpgrade is really your friend. And it does a lot of things. Flint is one of these small tools who does just one thing and does it good. And that is to all the old string formats or old dollar percent formatted strings. It converts into F strings and very, very accurate. And if you're working with Django, two competing products, Django Upgrade and Django Code Mod, they both try to get you, I think, from a Django 2 and then successfully until Django 4. And if you're working with Django, a lot has changed between 2 and 4, so it will, again, save you a lot of time. And if you're really adventurous, you can roll your own. libcst is normally the weapon of choice where you build these kind of tools with. It takes a bit, you have to take a bit of a deep dive into what concrete syntax trees are. And, but at the end of the day, it's not rocket science. You can do it, but it's a bit daunting. It is a steep learning curve at the beginning. Yeah, lots of these things, of the tools I mentioned before, also can be accessed as a software as a service software these days. They don't normally use the tools I spoke about so far, but more probably AI-oriented approach to that. And yeah, Sorcery does a very good job. I've been using that for years, and it's getting better and better. Sonar Cloud is their direct competitor. They are very good as well. So MetaWop is a bit of a newcomer, but honorable mention here. And we talked earlier about measuring code coverage. So Coverage.io is a really good software as a service which does annotate your test coverage directly in your pull request on GitHub or Bitbucket, and you know exactly what lines are covered, what lines are uncovered. So, and yeah. Okay. So, up to now, we talked only about refactorings pretty much line by line. That is most likely, if you have a really old code base, not where your problems lie. So your problems lie more in the architecture. But make no mistake, during that way to format and type annotate your code base, you will already then see patterns emerge. Okay, there is duplicated code. Let's put this into a function. It's not that those tools are useless when you want to go for here. So you have good advice, like don't repeat yourself, or write everything twice, wait for patterns to emerge, and then, yeah, the solid and qubit principles. So solid, every software engineer should know that. It's really, an object should have a single responsibility. There's an open, closed, so open for extensions and closed for, sorry. And you can't, closed for modifications, sorry. You have the list of substitution principle, which is really nice because MyPy already flags that up. If you use MyPy, you don't have to worry about what list of substitution principle means. It will spot it for you and tell you what to do about it. And then in the interface segregation, dependency inversion, that's a whole other car. Cupid started out as a lightning talk. The lightning talk was titled, "Why Every Single Solid Principle is Wrong." And then he came up with the Cupid principles, which are composable, plays well with others, Unix philosophy, predictable, idiomatic, and domain-based. I never, if you read both of them, they are, at the end of the day, they are not really that different. They are, but yeah, keep your code small and simple so that you can work with it. And when I say principles here, it's not like Newton's Principia. You can't argue with gravity. You can argue with any of that. And they are only means to achieve an end. We want our code to be maintainable, extensible, and modular. And that is pretty much where all the solid and Cupid principles go into. Okay. You won't be perfect. There will be lots of things like casts, no QA, this error, though this line doesn't have a security implication in it actually, or yeah, type ignore, yeah, I don't know how to annotate this at this time here. Maybe I do it later. But we are now in a kitchen, we can actually get stuff done. So, in summary, we had a short look what hypermodern Python is, what it means, why we would like our code base to be more hypermodern, and yeah, a few tips and tricks how to hypermodernize your legacy codes and what you want to do after that. Okay, done is better than perfect. That goes for talks too. Thank you very much. And slides and a lot of more links are here on the URL.
Thank you. We have some time for questions. So you've presented, frankly, an overwhelming amount of tools. Which gives you the most bang for your buck? Like demonstrably, reduces bugs, or faster QA cycles, or less fights among the team?
I think the typing has the greatest impact, but you won't go. You really won't look into typing if you haven't done the other things. And the other things are easier to get a buy-in from your team. So nobody argues about import order, more or less. Yeah, I thought that's a brilliant job with it. Then black, you may have some backlash against that. But in the end, yeah, God, I don't care about if it's single quotes or double quotes. Just get over this. And yeah, but typing then really, and then also testing your code with MyPy, that gives you a real bang for the buck.
Sorry, 1 second.
You discussed about a hypothesis and ghostwriting, right? So, like when we talk about TDD, test-driven development, isn't that the same? So, what is ghostwriting and hypothesis are bringing to the table in addition to that?
Yeah, hypothesis is yeah, it is like a really strict QA person that tries out every input that could possibly go wrong. Big strings, small strings, float. Do you handle float NaN? Yeah, all these kind of things. It throws a lot of test data at it, and then you look at the output. Does it still have the format I expect, or does it throw an error in between? Mostly, the most bugs I have found, it just yeah, runs into an exception somewhere, and then yeah, you fix the exception and then I haven't thought of that.
I have a couple of questions. The first one is sometimes when you use MyPy,
Yeah.
you have to look a lot for the types, so happens errors and so on. Which one of the tool do you recommend for, which is the best for inferring type and then pass it through MyPy for speeding up the process?
Yeah, I think monkey type. Monkey type is yeah, the one where I had really big, good experience and success with. At monkey type, you normally run it with your tests, which means some functions get annotated with mock.magicmock. That means, yeah, you never actually test it with real data. You can run monkey type in production, but it slows down your code quite a lot. So factor 2, 3 more. So maybe on a QA instance.
We lose a lot of time correcting MyPy definition because we have a lot of legacy type.
It takes less time than to build annotations from scratch.
Okay. The second question is, you mentioned at the point a tool that looked at me like fuzzy testing, Moot or something like that. Do you recommend any fuzzy testing tool?
I didn't get that. What?
Fuzzy testing.
Fuzzy testing. Yeah, hypothesis. Yeah. Or did you refer to mutation testing? Yeah, the mutation testing is, yeah, it changes your code in tiny and subtle ways. You will probably not see. And then you run your test over it again, see if the test breaks. The test should break when something is changing your code.
How much test is effective?
Oh, effective. I had good experiences with it, with finding yeah, edge cases I haven't thought about I wouldn't have thought about in a million years probably. But
Yeah.
mutation testing takes a lot of time.
We have time for last question.
What's the relationship between hypothesis and, say, something like a general fuzzer like Atheris or that OSS Fuzz uses?
I am not entirely sure how these fuzzers work. Normally, the fuzzers just throw data at it and see if something breaks. Hypothesis sees, okay, something breaks. Now, can I reduce my input to the minimum that breaks the test? So it really tries to pinpoint what is wrong with that input.
Thanks, Christian. Thank you so much.